Okay, so for today, I'm actually going to record the class lecture for today because I do have a meeting on Thursday morning, so I won't be able to be with my first period IM2. So I was like, okay, well, I might as well record this lecture for all of my classes, and I can focus on talking to certain students about their grades during class while you guys watch this lecture video. So without further ado, here we go. So you guys should have a Jamboard in Google Classroom on today's assignment. So of course, always put your name here. Hopefully you have a stylus by now. If not, email Mr. Kenneth Gregory. Your day, it's either going to be Thursday the 17th or Friday the 18th. And then whatever period you're in. Once you are done with these notes, you do need to download them as a PDF and turn them into the Google Classroom assignment. So it's basically just documentation that you are watching the video, you are doing your class notes, and then do not forget to do your homework. You do have a video to watch to take notes on, a Khan Academy review to take notes on, and then you should do your Khan Academy assignment. So always do the videos first just to prepare you for the assignment. Alright, so the first problem, lesson 212, that we're going to do is 2-12. So we have to examine the two triangles at the right. Are they congruent? If so, which triangle congruence theorem ensures that these triangles are congruent? So let's remind ourselves, we have 5 triangle congruence theorems. And also, by the way, I'm not going to pause during this video. So if it's going too quickly, you need to pause it for yourself in order to make sure that you get everything down that you need, that you understand it, and then we'll go from there, okay? So the 5 triangle congruence theorems, we have side, side, side congruency, side, angle, side congruency, angle, side, angle congruency, angle, angle, side congruency, or if it's a right triangle and we have the hypotenuse is congruent and corresponding legs congruent, we can use HL, okay? So these 5 are what we're going to use to help us prove two triangles congruent. So the first thing you guys have to do is start marking your congruent parts. So again, I would use colors. So here we have AB is congruent to FD. So I'm looking at the corresponding parts, okay? So that's a side that is congruent. Now, what I will have you guys do eventually, we're going to use a table to organize our proof, okay? So on the left side, we're going to have the statement, like what is true about the congruencies, and then on the right side, we'll have the reason that we know it's true. But before you guys start setting up a proof, before you do this, you need to finish labeling everything to see if they're even congruent, right? Because why waste all the time writing down all the statements if they don't even end up being congruent, right? So I'm going to keep on marking this up. So we have that side congruent, and then I also have BC is congruent to DE, and that's another side that's congruent. Sorry, I need some water. Alright, so another side that's congruent, we have CA is congruent to EF. Okay, and that's another side. So it's looking pretty good here. It looks like we have side, side, side congruency. Okay, so we have 3 statements to make here because there's 3 parts, whereas like with HL it'd only be 2 parts here, right? So for the statement here, the first, second, I just like to put numbers here to like keep them organized. So then like you know which reason goes with which statement for sure. So our first statement can be that first side that we marked. So we said AB is congruent to FD, and I'm looking at the corresponding parts. So like the A is next to the green and the orange, So I have to pick the F that is also next to the green and the orange sides there. Remember, you could always like do shapes, if you really wanted to, that would be fine too. It's totally up to you, just whatever helps you see the corresponding parts of the two congruent triangles, okay? Our reason here is they told us the length. They said that they're both a length of 6 units, so it was given to us. We were given that information. Now I challenge you to pause the video and try to do the rest of this one on your own and see if you can do it. That's the best way to learn, is see if you can do it on your own and then see how I do it, okay? So then now for the blue, we know BC is congruent to DE. And again, that one was given. We were told that they both have a side length of 4.5 units, okay? And then we have side CA is congruent to side EF. And again, that one was given as well. They're both 7.5 units. Okay, so with this knowledge, we know that our reason why we know that they're congruent is side, I like to use the colors of the sides, side congruency. Okay, so this helps us see that we can now state that triangle ABC is congruent to triangle, it'd be FDE. Okay, so again, pause the video, make sure you understand that problem before you move on, okay? This is, oh dear. So a flow chart, I forgot to read this, I'm sorry guys, but this is what we would call a 2-column proof. So I'm going to show you guys what they mean by a flow chart as well, okay? So that's a big oops on my part. I'm going to make this just a little bit smaller. So a flow chart, I just instantly start going into 2-column proofs. So there's 2 different ways to write proofs. The 2 columns is one way, and then the flow chart is another way that you're going to want to understand how it looks. So you have bubbles with the flow chart. Okay, it's still the same information, but here, since I have 3 parts to this triangle congruency, again, if I only had 2 parts over here for HL, I would just have 2 bubbles. But since we have 3 parts, I'm going to draw 1 bubble here, a bubble here, and a bubble here. And then all these bubbles are going to go down to prove to me that what we're trying to prove is that, again, triangle ABC is congruent to triangle FDE. Okay, so you put the statements inside, and then you're going to be putting the reason why the statements are true on the outside here. So it's going to look just like our 2-column proof. So what I'm going to do, since I have this ability, is I'm just going to take these parts and copy them over and put them in there. Okay, so that's my first statement, and I know that those sides are congruent because they were given. And then I have my second statement, and I know those sides are congruent because they were given. Okay, and then I have my third statement, and I know those sides were congruent again because they were given to me. And we know that the 2 triangles are congruent by side, side, side congruency. Sorry about that little mix-up, but there are two ways to write a proof. This is 2-column proof, flowchart proof. Okay? All right, so again, pause the video if you need to get that down. I'm moving on to the next question. Okay, so this one says again, make a flow chart. Miss Champlin, a flow chart. But I'm going to show you guys also the 2-column proof anyway, because I can just duplicate my parts and show you guys how to do that pretty quickly. Right, so the 2-column, we have statement, reasons. And you know what? It actually tells us that, showing that the triangles below are congruent. So we know that they are congruent, right? So that's why I'm setting this up, just because we already know they're congruent. So we are good to go. All right, so that's the flow chart. And we want lines to be able to give the reasons. Now, if you forget to include the reasons, that means you only did half of the flow chart. Right, so you guys cannot forget to write the reasons next to the bubbles. Okay, so the first thing we do is mark our congruencies. Okay, so I have here a side. PQ is congruent to this side. It would be PQ and TS, it looks like. And then we have an angle here. This angle 120 degrees. Is congruent to this angle 120 degrees. And then you have to recognize that you have vertical angles right here. So where those two lines cross, they create vertical opposite angles here. So in order to determine, this one is not, it's not angle side angle. You have to go all the way over, right? If it was angle side angle, the other angle would have to be right here. Okay? But this one, if you notice here that what's all connected, we have angle, angle, side. And then you want to make sure it's the same here. So angle, blue angle, green angle, orange side. And they are the same. Okay, so we know that these are congruent by angle. The blue angle goes first, the green angle goes next, and then the orange side is last. So we know these are congruent by angle, angle, side congruency. So I'm going to go ahead and put that at the bottom here. We know they're equal by angle, angle, side congruency. Sorry, my dogs are waking up. So here we have the first angle. We'll do the blue one here, and then we'll do the green one here, and the orange one here. And you guys always want to go in order, okay? So the blue angle, if I were to name the first blue angle here as QRP, so angle QRP, then the next one will have to be I need to go with the blue angle. It would have to be SRT. Okay, so I'm just looking at the corresponding parts. And again, those two are not given, right? We said those two angles are vertical angles. That's how we know that they're congruent. They did not tell us that they're congruent. We had to use our knowledge of angle pair relationships in order to say, oh yes, those are vertical angles, okay? All right, and then we have, for this second angle, we have RPQ, or you could always say QPR, but I'm going to go and put RPQ. And then following that one, it would be RTS for its corresponding parts. And that one was given. They told us that they're both 120 degrees. And now for the side, we have PQ is congruent to TS. That one was also given. We were told that each of the side lengths units was 6. So now that proves to us that triangle RPQ is congruent to triangle RTS. And the flowchart proof is done. Now I'm going to quickly fill in the 2-column proof from this information. Okay, from that same information there. So the first one we said woohoo. We said that these two angles were congruent because because they are vertical angles. So you guys notice in the 2-column proof, I'm also going to follow the order of the angle, angle, side. Okay? So then we have this angle here. And you guys do not always have to do two different looking proofs, but I just want to show you guys both of them. So if a problem does not specify it, you can pick which one you like better. But if it says a flow chart, then I need to see these bubbles. Okay, if it says a 2-column proof, then I need to see this table, right? So you just have to read the directions carefully. Sometimes it'll just say, prove the 2 triangles congruent, and then you can use either one. All right, so then for this one, we have PQ is congruent to TS. And by the way, I'm sorry for my throat being so scratchy. I'm not sure what's going on. I think it's my allergies. Oh, I forgot to write given here. Given. And then given. So again, we had said triangle RPQ is congruent to triangle RTS. And we know that because angle side congruency. Okay, so go ahead and pause and make sure you have everything down. I'm moving on to the next problem. Okay, so this number 14, it says here, suppose you were working on a problem involving the 2 triangles UVW and triangle XYZ. Oops. I'm going to underline that. That's important. And you know that triangle UVW is congruent to triangle XYZ. What can you conclude about the sides and angles of triangle UVW and triangle XYZ? Write down every congruent statement involving sides or angles that must be true. So I'm just going to make a little list here. So for the sides and the angles. Now, what we need to do, though, to help us kind of visualize this a little bit better is we need to draw 2 triangles. So it doesn't really matter what they look like. Okay? So they tell us the order of which they're corresponding. Here, actually, I'm just going to duplicate mine because I can. There we go. All right, so I'm going to go and use some color here. So I'm going to say U is orange, so X is orange. Okay, so I'm going to pick like that part to be orange. So again, highlighters, super handy. V and Y are corresponding. So they have to be in the same type, the same part of the triangle. And then W and Z are both corresponding. So what I'll do here is now I know that one's U, this one is X, V and Y, W and Z. Okay, so we know that UV is congruent to XY. All right, so we know UV is congruent to XY. So these are what they're wanting. They're just wanting the statements of what is congruent within the 2 triangles. Okay. I know I'm probably going to need more room for the angles. And then we also know then VW is congruent to YZ. And you guys notice as I'm doing this, I'm marking using tick marks what are congruent, what sides are congruent. And then we have UW is congruent to XZ. Again, I highly recommend you try to pause and see if you can do the rest on your own for the angles. So looking at this too, we know that this angle here is congruent to this angle here. So this angle could be UVW. And you could write it as WVU. It just depends on what you prefer. But for mine, I'm going to write UVW. So then I have to write the corresponding parts. UVW is congruent to XYZ. And then I also know that this angle here is congruent to this angle here. So that'll be angle VWU, if I go this way, YZX is congruent to angle YZX. Okay. And then last but not least, we have this angle here. You could do three marks or just like an arc with the line. So all three angles are still marked differently. So if I call this one WUV, is congruent to ZXY. That angle there. I don't know why I did that Y different. Alright, so go ahead and pause the video. Make sure you have all of this down. Make sure you understand. And then you can move on to the next problem. Okay, so here it says, Callie started to prove that given the information in the diagram at right, side AB is congruent to side CD. Copy your flowchart below, but luckily you don't have to. It's already there in Jamboard. And we want to help her justify each statement. So first I would start using color and see what's congruent here. So I do have this angle here is congruent to this angle here. Okay? And then that one is given. So it says here angle C is congruent to angle C. Alright? Now normally I would not write it like that. I would be like DAB and BCD, but it's okay. So this one would be given. Also, the fact that we have two parallel lines, so they tell us here with these parallel lines, right, the side is not congruent. We just know that they're parallel. We don't know if those sides are congruent, and that's the thing students make a mistake on very often. If they're marked with arrows, we only know that they're parallel. So the double line there means parallel, not congruent. Okay, but it was given to us that they are parallel to each other. That's going to help us with this angle here. Okay, so looking at angle ADB, I'm going to go and mark it ADB, and angle CBD, they're saying that they're congruent. Okay, but we want to know why. If you guys extend out the parallel lines and look a little bit closer, and then you see that both of these angles here are touching that middle line. So that will be the transversal that we want to extend out. Okay. Like that. So now if you guys look closer, you can see that we have alternate interior angles. Okay. And also might be easier like if you guys maybe try to rotate this. Here, I'll just try to show you it. If I were to rotate this, right? So if I were to rotate it like this, it's a little bit clearer for you because you guys are so used to the parallel lines going like this, you know? And then you have this transversal here. Well, that was not pretty. You have this transversal here, so you can see then that these are alternate interior angles, right? So that's how you guys would want to go about that. Okay, so again, hopefully if you did not have enough time to see that, just pause the video and go back to see what I just did. But I just showed you guys why these are congruent, and it's by alternate interior for these angles here. Alternate interior angles. That's the reason that those two angles are congruent. And then we have right here, we have side BD is congruent to DB. And if you had done some review, in which you'll see today in a video and in the review article you have to take notes on, this is called the reflexive property. Whenever they lie right on top of each other, we know that they are congruent by this property, reflexive property. So now that shows us that triangle ADB is congruent to triangle CBD, and this is by, forgot to put the little angles here, angle, angle, and then side. Okay, so if you look at the order of them, you have to make sure, so it goes angle, angle, side. So everything's like attached, right? Angle, angle, side. Okay, so it is angle, angle, side. So here I'm just going to write angle, because that angle here. Angle, because that angle there. Side. And you guys do always want to try to set up like your flowcharts or your 2-column proofs to be in order of the triangle congruent statement. So you want the blue angle to go first, then the green, then the orange side. Okay. So now it's saying, okay, so therefore side, and this is what some students get confused about. We just proved that the two triangles are congruent. So now it's like, okay, well then now how do I know that side AB is congruent to side CD? Well, if the two triangles are congruent, we know that corresponding parts of congruent, it's just a logic thing, right? Corresponding parts of congruent triangles are congruent. So those two corresponding sides are congruent if the triangles themselves are congruent, right? We could prove every single angle and every single side is congruent, just like up here in problem 2-14, right? If we have two congruent triangles, we know all of the sides are congruent, all the corresponding sides, and all the corresponding angles are indeed congruent, okay? So that's what we're saying here. So this statement, corresponding parts of congruent triangles are congruent, you may also see stated as C, corresponding parts of congruent triangles are congruent. So that's CPCTC. CPCTC. So like in my proofs class in college, if I had to do this, I would just write CPCTC to say that, you know, that the corresponding sides of a pair of congruent triangles are congruent because the triangles themselves were just proven to be congruent. Okay? So again, pause the video, try to wrap your head around that, make sure you have everything down. Okay, so for this one it says, in each diagram below, determine whether the triangles are congruent or not. So I would really, really like you guys to pause this and try to do it on your own first. You will learn so much more if you try it on your own and learn from mistakes or see if you can figure it all out correctly than you will just copying down what I'm doing. Okay, so I fingers crossed you guys pause the video and try it out for yourself. Okay, so before I even draw flowcharts, I'm going to mark what is congruent. Okay, so I know here I have this angle that's congruent here. And then I have this reflexive side, the reflexive property. So this side is congruent to each other. And then I have some parallel lines. And I have one transversal here. Okay? So that shows me that here I have alternate interior angles that are congruent. Now it cannot be these angles here because neither one of those is touching the parallel line or it does not lie against the parallel lines. So it has to be the two that I marked here. So now if we look carefully, do we have a triangle congruent statement? So here we have orange angle, green angle, blue side. Orange angle, green angle, blue side. So we do have a triangle congruence. So the first angle would be the orange angle. So I'm going to write this down below for the bottom of our flow chart. And then the green angle. And then the blue side. You know what? I'm going to zoom in a little bit just so you guys can see this clearer on the video. So now that we know that they're congruent, it's by angle, angle, side congruency. So I'm going to draw 3 bubbles. Each one needs to have a reason. And then one main bubble is just saying that they are indeed congruent. Okay? So what you put in the first one is that first angle. So we have angle CDA. is congruent. So I'm going to need to write a little bit smaller here, or I'll just make this guy bigger. Okay, is congruent to CDA to ABC. And look very carefully to make sure you understand why I'm ordering them in this way. And that one was given to us. That one was marked before. So like if you look at behind it, it was marked for us. Okay. And now we have the green angle, which was not marked for us, but we know angle DCA is congruent to angle BAC. And that one is by alternate interior angles. Okay, we know that to be true because we had those parallel lines. So then for S, the side, we want to say AC, and then technically we have to flip it because like A is next to the green angle, so now we have to say C is next to the green angle. So it's going to be AC is congruent to CA by reflexive property. So now we know that triangle ABC, or here, I've been using the left one first. Triangle CDA is congruent to triangle ABC. And you're done. That's the flow chart. So you were done proving that those two triangles are congruent. So again, pause the video. I'm moving on to the next one. So again, the first thing you want to do is mark your congruencies to see if they even are congruent, because we don't know yet, right? But here I have this 50 degrees. So we have an angle that's congruent to each other. And then we also have some vertical angles right here that are congruent. But we know nothing else. Nothing else. 5 is not equal to 4. So the sides are not congruent, and we have no idea about this side. I mean, who knows? Maybe this side equals that side, but are there any markings? No, right? So we don't know. So we only have two angles. With these two angles, there is not enough information to prove the two triangles congruent. And that's because we have to choose from SAS, SSS, angle side angle, or AAS, or hypotenuse leg. So in order to use both angles, it has to be one of these two, but we don't have any sides that are congruent. So it's impossible for us to prove that these two triangles are indeed congruent. Right, so moving on to part C. Okay, so here we have a few things here. So technically we could solve for this side length here, like because we're given the 2 and the 3. Using Pythagorean theorem, 2 squared plus 3 squared should equal, let's call this x squared. So we have 4 plus 9 equals x squared, the square root of, not yet. 13 equals x squared. Take the square root of both sides, square root of 13 equals x. But we don't know this one here, right? And so, like, if you guys look here, I solve for this, right? I know x is 13, so I could solve for this one, but there's no way they're going to be equal because my legs are different. This triangle has leg lengths 3 and 2, and then this triangle has leg lengths 3 and 6, right? So it's not going to work. Yeah, this one, we literally, the only thing, sorry, I keep accidentally erasing that. The only thing we know about this one, the only thing we know is that they both have a right angle. But other than that, like, that's it. Those are the only congruencies we know, is that those two angles are congruent to each other. So this one, again, is not enough information to prove them congruent. There's just no way. Like, you can definitely solve for sides, but those sides are not going to be equal because we have two different lengths for the legs of these triangles. So there's just no way that we can prove these equal or congruent. Okay, so moving on. Pause the video if you need to. Alright, now this one here, let's see here. So I see right away that we have hypotenuse of the right triangle. So you can either call it a side or the hypotenuse. So I'm going to write, make it right a little bit nicer. S or H. We don't know yet. We might use side, side, side. Or we can use HL. So we don't know yet. But we just know with this right angle we can use HL if we want to. And then I'm like, crap, well 12 doesn't equal 5, but we do have like this blank side, and since we have a right angle, we can use Pythagorean theorem. So if you guys were confused about what I did on the last problem, it's a squared plus b squared equals c squared. So we have a, b, and c. So it doesn't matter which of the legs is a or b, just they each have to be one of them. So if I start to plug in these numbers here, so here I have a squared plus b squared is 5, so 5 squared equals, I have 13 as my c, 13 squared. So now if I start simplifying, a squared plus 25 equals 169, and then I subtract both sides by, not 24, I don't know where I got that, sorry, from 25 minus 25 minus 25. So now we're left with a squared equals 144. If you take the square root of both sides there, that will tell us that a equals 12. So now we know that a is equal to 12. And what do you guys notice about that? We have another side that's 12. So if those sides are 13 and 12, this side here must also be 5. And I'll prove to you why it should be 5, right? So again, if you use Pythagorean theorem, let's say this is, so this one we marked as B earlier, BAC. So again, if we have a squared plus b squared equals c squared, if my a is 12, so it'll be 12 squared plus b squared equals, my c is blue, so the c is 13 squared. Now we simplify. 12 squared is 144 plus b squared equals 169. So if you subtract both sides by 144, we have b squared equals 25. Take the square root of both sides, b equals 5. So we know for a fact that yes, like since the other two sides were congruent, that third side is also congruent here because we have a right triangle. We know that they're all related. So for this one, you could make a flowchart of either side, 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 or HL. But since we haven't done an HL one, I'm going to take this time to show you guys what an HL flowchart would look like. So we have, use a different color here, use black. So we have the hypotenuse is the 13. Okay, so these two are the hypotenuse. Okay, so that's the hypotenuse. And I said you can use side, side, side. Yes, you can use side, 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 but I just want to show you guys. And then we're just going to pick one of the legs. It doesn't really matter which one. But we know this leg is congruent to that leg, and we use the Pythagorean theorem to solve for that. So here, we only need 2 bubbles for HL. Okay, so again, the hypotenuse is that blue line there, so that one will go first, the hypotenuse. And then we picked the orange one for the leg. It doesn't matter, but that's what we picked. So we need our lines going down, and then the main statement. So our main statement is that these two triangles are congruent by HL, or hypotenuse leg congruency. Congruency. All right, so we need reasons still. I'm going to move this guy over here. so I have more room to write this reason. The hypotenuse, the 13, okay, we can say MN is congruent to QR, and they told us that that side length of the hypotenuse was 13. So they gave us the information. It was given. Now, the legs, on the other hand, we did solve for them, for these legs, for that one on the left. We knew one of them was 12, but we can't just assume that the other one is 12. But in order to prove that KL is congruent to RQ, we used our knowledge of the Pythagorean theorem. So what we had done was, using the Pythagorean theorem, we knew two of the sides, right? Oops, sorry, no, on this one, sorry. We knew the 5 and 13, so that allowed us to solve for the 12 here, for that other leg. So we used the Pythagorean theorem. So now, knowing this, we know that triangle, we'll do KLM, is congruent to triangle RQP. Oh, wait. Oh, no. It would be RPQ, sorry. Because if I go K orange to green to blue, KLM orange to green to blue. Okay, so RPQ. Yeah. RPQ. Alright, and that'll do it. We are all done. Okay, sorry, I tried to keep this as short as possible, but hopefully you feel confident now with flowcharts and two-column proofs. So again, these guys here were flowcharts for the ones that were congruent. Okay, and those were flowcharts. Alright, so feel free to email me if you guys have any questions. Now, go to your lesson document and watch the video attached there and take notes. It is shorter. I believe it's less than 10 minutes long. But please try to do that before you do today's homework, okay, on Khan Academy. All right, have a great weekend. We're almost there. Bye, guys.